today's video, we are going to see the problems from electronic devices and circuit session. So we have already uploaded a video on the formula revision of electronic devices and circuits, covering all the equations from the semiconductor devices, BGT, and all the important equations. So in this video, we'll be seeing some problems based on that important formulas. Okay, so this is a part 1 of numericals from the electronic devices and circuits. Let us see what is the first question. So the intrinsic carrier concentration of silicon sample of 300 Kelvin is 1.5 into 10 raised to 16 per meter cube. That is, we are being given the value of intrinsic carrier concentration. If after doping, majority carrier concentration is 5 into 10 raised to 20 per meter cube, full stop, the minority carrier concentration is dash. Okay, so they have been given the value of intrinsic carrier concentration and also majority carrier concentration is being given. We need to find the minority charge carrier concentration. This is a direct equation. You just have to know this relation or law, mass action law. So this is N0 P0 is equal to Ni square. That is the concentration of, we can also write it like this, majority carrier concentration into minority carrier concentration is equal to intrinsic carrier concentration the whole square. So here we have been given the value of majority carrier concentration and also intrinsic carrier concentration. So in order to find the minority carrier concentration, I have also explained that as a separate equation in the equation video. So the minority concentration is equal to Ni square. I'm just writing it as a term, Ni square, that is intrinsic carrier concentration square by doping concentration or majority carrier concentration is the equation. So what is Ni here? It is 1.5 into 10 raised to 16 the whole square by what is the concentration of majority charge carriers? It is 5 into 10 raised to 20 is the majority carrier concentration. Okay, so if you solve it, you will get the value of minority concentration. Okay, you will get. So if you solve it, you will get the value as 4.50 into 10 raised to 11 per meter cube is the value. That is, your option A will be obtained as your answer. 4.50 into 10 raised to 11 per meter cube. So this is just a direct application question. You just need to know the mass action law. That is, the product of majority carrier concentration into minority charge carrier concentration is equal to your intrinsic carrier concentration square. So in order to find the minority carrier concentration, you have to divide the intrinsic carrier concentration square by the majority carrier concentration. So you will be getting 4.50 into 10 raised to 11 per meter cube is your answer, and your correct answer is option A is your correct answer here. So the next question that we are going to do is this. This is a little bit tough question. First, we'll try to find out what is the meaning of this question. That is what we have to find from the question. I'll read out the question first. The energy band and electron density profile in a semiconductor are shown in the figure. So we have been given two graphs in the figure. So first graph is indicating the energy band diagram, and second graph is indicating the electron density profile n of x, that is log n of x graph is being given. And also we have been given the electron density profile n of x equation, that is 10 raised to 15 e raised to q alpha x by kt. So this is the electron density equation or profile equation. And we have been given with alpha is equal to 0.1 volt per centimeter, x is in centimeter, it is also been given. And also given kt by q is equal to 0.026 volt. Also diffusion constant dn we have already discussed in the formula video that dn and dp are diffusion constant for electron and hole. Okay, so dn is being given as 36 centimeter square second raised to -1, and it is also being given that D by mu is equal to KT by Q. This is one important relation we have also discussed. That is diffusion constant by mobility is equal to KT by Q or the thermal voltage. Okay, so I request you to, if you are seeing this video, just go and see the equation video first and then watch this video. That will be very helpful for you. Okay. Then the electron current density in ampere per centimeter square at x is equal to 0 is dash. That is the equation. That is, we need to find the electron current density. Okay. So we have to find what? We have to find J, or the current density. We know that current density is equal to current by area, right? So here we have to find the current density at x is equal to 0. We have to only find the current density of electrons and we have to find the value at x is equal to 0. So before going into the current density, finding all those things, just try to understand that if you are considering the case of an electron, the electron current density J is contributed by two things. Okay, the electron can undergo drift and diffusion. So the current density is contributed by drift and diffusion. Okay, so the total current density is the current density due to diffusion and current density due to drift. So we have to find first the diffusion current density and then the drift current density. Then we have to add both. Okay, so how will we find the diffusion current density? First, let us talk about that. The diffusion current density J1 I am going to call it. So J1 at x is equal to 0 will be what? It will be equal to Q into dN, diffusion constant, into differential of electron density profile dnx by dx. Okay, so this is the equation. So we have not discussed this equation in the earlier video. So just note this down. This is the current density due to diffusion. Q into diffusion constant into the electron density profiles differential. So this is how we calculate the diffusion current density. That is, diffusion means due to the movement of the electrons, the current is happening, or diffusion is actually diffusion of electrons. So we have to take the differential with respect to the distance dx, dnx by dx. So in order to calculate the diffusion rate, we do this, and into diffusion constant into the charge of a electron. Here we are taking electrons, so Q is equal to 1.6 into 10 raised to minus 90. Very simple, right? So we know the value of, we should know the value of Q, okay? It won't be given in question sometimes, so you should know the value of Q. Then Dn is also given in the question, so it is 36 centimeters square, second raised to minus 1. And we need to find the value of dnx by dx. Okay. So here nx is being given. Nx is equal to, I'll write it again, 10 raised to 15 into e raised to q alpha x by kt. So this is the value. This is the value for nx. So take the differential dnx by dx and put x is equal to 0. You will get the value as 3.846 into 10 raised to 15. This will be your value. Okay. So dnx by dx is 3.846 into 10 raised to 15. Now substitute this value in your equation for J1, that is at x is equal to 0. This is actually the diffusion current density. So diffusion current density is equal to, what is the equation? Q into dn into dnx by dx. So it will be, Q is 1.6 into 10 raised to minus 90 into 36 into 3.846 into 10 raised to 15. Okay, if you solve it, you will get it as, take the product of these three terms, you will get the value as 2.21 into 10 raised to minus 2 ampere per centimeter square. Okay, so this will be your value for diffusion current density. We have obtained the value of the current density due to diffusion. Next, we have to find the value of current density due to drift. Okay, so let us try to first write the general equation. Okay, so what is this equation we have already discussed in the video, that is the formula video. So what is the equation? I'll call it as J2, that is the current density due to drift. The equation is N into Q into mu into electric field. This is a general equation. Here what is N? N is the number of electrons. Here the value of Nx electron density is given. So we'll take Nx at x is equal to 0. We need to find the value of current density at x is equal to 0, right? So we'll take the electron density profile and put x is equal to 0 to get the number of electrons. Next, Q we know. The third term is mobility. Mobility we don't see anywhere in the question, right? But we have been given this relation that d by mu is equal to kt by q, right? We have been also given the value of kt by q. So we know the value of d, we know the value of kt by q. So we can find the value of mu, right? So what will be mu? Mu is equal to d into, okay, we can take this term together. So d by kt by q. We know the value of d. D is actually here dn, diffusion constant of electron it is. So it is dn by kt by q. Okay, so directly we can substitute. So we will substitute mu as dn by kt by q. Okay, simple. Next, there is another term called E. Now, how will we find the value of electric field? Here, the value of E is being given as minus 0.1 volt per meter. So, we know that it is the electric field value given. So, it is minus 0.1 volt per meter. Okay. So, now we know all these values. Just substitute and find the result. First, we will try to find out what is Nx, the number of electrons at x is equal to 0. So, what is the equation? It is 10 raised to 15 into e raised to q alpha x by kt. So, here we need to find the value at x equal to 0. So, in the e raised to term, there is a x. So, put x equal to 0. So, we will get e raised to 0. So, that is 1. So, what is the value of electrons? This 10 raised to 15. Okay. 10 raised to 15 it is. Now, 10 raised to 15 into q is 1.6 into 10 raised to minus 19 into dn is, what is the value of dn? It is 36. 36 by kt by q is 0.026, right, into minus 0.1. Okay, so this will be your all terms values, all values we have substituted. Okay, so this is your J2. So earlier I'm just writing the value of that current density due to diffusion. We have obtained the value as 2.21 into 10 raised to minus 2, right? So this was our earlier value. Now if you take these products, you will get the value as, what value you will be getting is 2.21 into 10 raised to minus 2 into minus 1 you will be getting. That is minus, you will be getting a minus 2.21 into 10 raised to minus 2 you will be getting. This is ampere per centimeter square as a unit. So, the current density due to drift is obtained as minus 2.21 into 10 raised to minus 2. Earlier, the current density due to diffusion was obtained as 2.21 into 10 raised to minus 2. So, we need to find the total current density, that is taking the sum of this drift current density plus diffusion current density. So, what will be the result? So, these two magnitudes are equal and opposite inside. So, the total current density J is equal to J drift plus J diffusion is equal to 0 will be your answer. I hope this is clear. So, this is how you have to do the questions. Okay. So, here in this question, we have been asked only the total current density, the electron current density at x is equal to 0. We have to figure out from this question that we have to take the sum of drift current density and diffusion current density. So electron current density is contributed due to drift and diffusion. So in this question they have been given the diffusion constant. So first find the value of the diffusion current density, then find the value of drift current density, then take the sum and you will be getting your answer. So in this question you will obtain the value of total current density is equal to 0. Okay, so this will be your answer. 0 is your answer. Okay, anyway, I hope this question is clear. I'll write the equations for drift and diffusion current density once again, just for you to note down. The equation for finding the diffusion current density, first I'm going to write J diffusion is equal to Q into, that is charge into, diffusion constant into d nx by dx, where nx is your electron density profile. Okay, that will be given in your question, don't worry. Next is J drift, that is the current density for drift, that will be equal to nx into Q into mobility mu n into, if mobility is directly given in the question then you don't have to worry much, but in this question they have not directly given the mobility, you have to find it from this relationship. Okay, so mu n into electric field. Okay, E. So these are the two equations for finding the current densities for diffusion and drift. So this is one of tough questions which you can face most probably in your GATE exams or the higher competitive level examinations you can find. Okay, so I hope this is clear. I hope this equation is also clear. That is nx into q into mu n into E. Okay, so also you should know this relationship that d by, write that also, d by mu is equal to kt by q. That is diffusion constant by mobility is equal to kt by q or equal to Vt, which is thermal voltage. A silicon sample A is doped with 10 raised to 18 atoms per centimeter cube of boron. Another sample B of identical dimensions is doped with 10 raised to 18 atoms of phosphorus. The ratio of electron to hole mobility is 3. Then a ratio of conductivity of A to B is dash. Okay, so here we need to find the value of conductivity, right? So what is the equation for finding conductivity? One sample is doped with boron, another sample of identical dimensions is doped with phosphorus. Okay, so here we have to understand two things. That one thing is that the first sample is being doped with boron, which is a acceptor impurity, which will be creating a lot of holes. Okay, next one is doped with phosphorus, so it will be creating a lot of free electrons. Okay, so we can write sigma, the conductivity of the first material, that is A, is equal to N into Q into, sorry, here it is P, P into Q into mu P. Since the first sample is being doped with atoms of boron, a lot of holes will be created. So the conductivity is mainly contributed due to the holes. So P into Q into mu P. Next, B, the second sample, the conductivity is given by the equation N into Q into mu N, because it is being doped with what type of atom? Donor impurity or donor atom. So N into Q into mu N. Lot of free electrons will be created. Now, if you see the number of holes present, that is 10 raised to 18 atoms of boron is being added. So, and also the number of phosphorus atoms is equal to 10 raised to 18. So, here 10 raised to 18 borons and 10 raised to 18 phosphorus. So, the number of electrons and number of holes created in both the materials will be equal to same, because the doping concentration is same, right? So, N is equal to Q here. So, we can write N is equal to Q. Now, we need to find the ratio of the conductivity. Sigma A by sigma B is equal to P into Q into mu P by N into Q into mu N. Right. So this is the ratio. Here P is equal to N. So we can cancel out. Also Q is equal to Q. The charge is same. Both case Q is equal to Q. So cancel out this N, P and also Q. So we'll get the ratio of conductivities of sigma A, that is sigma A by sigma B, conductivities of A to B as mu P by mu N we will be getting, that is mobility of hole to mobility of electron. And also it is being given in the question that the ratio of electron to hole mobility is 3. So this is hole to electron mobility. So the value of hole to electron mobility is 1 by 3, right? Since the electron to hole mobility is given as 3, the reverse is the reciprocal, that is 1 by 3. So conductivity of A to conductivity of B, the ratio of conductivities of A to B will be equal to 1 by 3 is your answer. Okay, so the correct answer is option B, which is 1 by 3 is the ratio of the conductivity. So in this question, here we know that both the doping concentrations are same. So the electron number is equal to hole number. And also we know that the equation for finding the conductivity is sigma A is equal to P into Q into mu P and sigma B is equal to N into Q into mu N for electron and hole, because we are using two type of dopants here. So if you take the ratios, we will be only having a change in the that is variation is only for the mobility term mu P and mu N, and also its ratio is being given as 3 is being given the electron to hole mobility ratio. So the conductivity ratio is 1 by 3 is your answer, and the correct answer is option B is your correct answer. Question is this: a silicon sample is uniformly doped with donor type of impurities with concentration 10 raised to 16 per centimeter cube. You should know this thing that donor type of impurities contribute a lot of free electrons and accepted impurities creates a lot of holes. That is vacancies of electrons they will be creating. The electron and the hole mobilities are 1200 centimeter square per volt second and 400 centimeter square per volt second. Assume complete ionization of impurities. The resistivity of the sample is dash. So we need to find resistivity. So we don't have a direct equation for resistivity, or resistivity we can write in terms of only conductivity, that is 1 by sigma. This term I have already discussed earlier. So sigma or rho or resistivity is equal to 1 by conductivity. And we have the equation for conductivity, that is equal to N into Q into mu N. So here the sample is doped with donor type of impurities, and also it is being given that assume complete ionization of impurities. So this sample is having a lot of or abundant number of electrons. So the conductivity is contributed by electrons, and what is the value of N? N is the number of electrons present. So here the donor concentration or doping concentration is given as 10 raised to 16. So that should be the number of electrons. So 10 raised to 16 into Q is the charge of an electron. So 1.6 into 10 raised to minus 19. This value you should know, because in most of the questions they may not give, because it is a very basic thing. You will be studying this from your elementary classes, right? So it is a charge of a electron into mobility. Mobility, it is being given that it is 1200. 1200 is the mobility of your electron. So this is your conductivity, and we need to find the value of resistivity. So rho is equal to 1 by 10 raised to 16 into 1.6 into 10 raised to minus 19 into 1200. And if you value as 0.520 ohm centimeter is your resistivity value. So the correct answer is option B is your correct answer, that is 0.520 ohm centimeter is the resistivity value. Okay, so if you don't know the equation for resistivity, don't get confused. Take the reciprocal of your conductivity, it will give you a resistivity value. Okay, so these are the questions which I have included in this video. We'll be doing lots of videos for preparation of EDC. We'll be doing videos including the questions and answers, and we'll be doing the formula revision videos. And also while discussing various questions, I'll be introducing new formulas to you. That will be helpful for you to understand, right? While doing the problems, if we discuss formulas, that is easy to understand and that is easy to remember. So I hope this video was useful for your preparation. If yes, please do give it a thumbs up and also share this video with all your friends. And if you want more videos, please do subscribe to the channel. Thank you.